2008 F250 with a 5.4 liter 3-valve engine. And this one's got some problems. The customer brought it into one shop and now has it in a different shop. The work order states that the check engine light's on at is a rough idle and lacks power sometimes. It has a new timing chain and gears, and the variable cam timing solenoids have been replaced as well. So basically, somebody's replaced all of the business items on this vehicle that run the variable cam timing system. So we have a problem here that is going past the replacement of parts. As soon as we scan the vehicle, we find we have a couple of DTCs, a P0012 and a P0022. This is intake cam positioning over-retarded. In other words, the system is not advancing properly to the default position, and this is bank 1 and bank 2 are setting the codes. And when we look at our service information, you know, it's vague as usual. It says that the DTC set when the camshaft timing exceeds a maximum value or remains in a retarded position. So they're not going to tell you what the value is that sets the DTC, but certainly we know the cam at some point are remaining in a retarded position. Now, the shopping list that we get from Ford is that the camshaft timing is incorrectly set. You know, that one is, you know, we drove this truck into the bay and it ran okay. We have, you know, that's the problem with some of these items. Now, the other possibilities are continuous oil flow to the piston chamber, the solenoid stuck, or we have a binding actuator. So the technician gets in the truck, starts it up, and it runs normally as he drives it into the shop. So if we revisit that shopping list, you know, we find that all of these items are suspect. You know, possibly variable cam timing solenoid is sticking from time to time, but remember, they're two brand new units. The actuators are brand new. And if the camshaft timing were incorrectly set, the technician's opinion is that it wouldn't run as well as it did when he drove it in the shop. Well, now we're going to take a look at a scan data recording. And this is done when the engine is idling and it still runs fine. As you can see, we have an advance command for the VCT is virtually 0 on both banks. And the error PID for both banks, VCT ADV ERR it's called, and the same thing with a 2 on the end. Both of those PIDs are at basically 0. And what we're talking about is right here where the vertical line is. These are the values that you see on the left-hand side. So we have variable cams that are currently in the correct position for an idling engine. Well, now the technician runs the engine at 2,500 RPM and lets it warm up. When he gets through warming the engine up, and lets it go back to idle, which occurs right about here, the engine now idles very rough. The other thing that he notices is his short-term fuel trim on bank 1 is adding about 13%, and bank 2 is now subtracting near 14%. So there's definitely a problem here. Now, some folks may recognize this type of fuel trim issue as being a crossed O2 sensor wires or a plug catalytic converter on one bank. In that case, if you had those problems, it would show up more off idle than it would at idle. You know, these values are being recorded out at idle right now. So we came off 2,500, and when we were running at 2,500 along through here, our fuel trims seem fairly normal. So you can see right as soon as we let off the throttle, the fuel trims skew. But the other thing that I want to call your attention to, which is much more serious than the fuel trim, is these two PIDs right here. We have a cam error for the first bank 1 of 41 degrees, and bank 2 is about minus 36. Well, we obviously have a cam that is not retarding to the proper position. The one that's not retarding is bank 1 right here. Now, why is bank 2 so far off? Well, the PCM uses bank 1 for its cam sensor. So, I mean, it has to have a cam sensor function on one of these two cam sensors besides the variable cam timing function. And because the cam sensor is currently in the wrong position, the PCM is not calculating the value for bank 2 correctly. So we have at least one cam stuck, and it happened just after we brought the engine to 2,500 RPM and let it go back to idle. So now the technician has to try to figure out what's wrong. He really doesn't believe that it's a mechanical misalignment of the cam and crank sensor. So he takes a look in the service information, and he sees in the service information basically has the same diagram that Ford used way back with the 2-liter. This diagram really isn't accurate to this truck because it's showing the cam sensor on the back of the cam, and that's not where it is on the truck. The cam sensor is in the front. But it does show the detail of the variable cam timing solenoid. The technician is left with this situation where he's got to decide what is wrong with the vehicle. Now, he understands that oil pressure is needed to advance and retard the cam. He knows the cams retard when the engine RPM increases, but when he returned the engine to idle, one of the cams did not move back to the nominal position. Also, he noted that the engine and the system works okay when it's cold, but not when it's hot. Well, the shopping list that Ford gave us is not going to be very useful. The final conclusion on this vehicle was that the oil pressure was inadequate at idle. The technician measured the oil pressure at the switch port, and with the engine completely warmed up, he had a value of 7 psi at idle. The specification that we found in the service information is 40 to 70, but they measured at 2,000 RPM. We had to do quite a bit of digging to find a minimum oil pressure spec for this engine, but we did, and it is 25 psi at idle. So obviously, we have inadequate oil pressure when the engine idles. Now, this shop had installed a lot of parts and had another shop do the diagnosis, and they needed to get rid of this truck. So what they did was put a new oil pump in. By installing a new oil pump, the engine ran smoothly at high RPM, low RPM, idle, and the vehicle was drivable. Just for a note on how this could have happened, you know, the gauge, quote unquote, you see on the dashboard on a Ford is really driven by an oil pressure switch, as you can see down here on the bottom. This is another specification that was very difficult to find, but we discovered that this switch closes somewhere around 3 to 5 psi. When it closes, it makes the gauge needle go to a position that makes the customer happy. It's obvious that this system could have low oil pressure and not have the gauge be down in a position that would alarm the customer or turn on the indicator for low oil pressure. So to summarize this system, make sure that it has clean oil and it's the correct type. If the car calls for 530, that's what's got to be in there. Quality oil filter has to be used. Make sure that the oil filter it has a check valve. It's supposed to have a check valve. And some, no-name brand oil filters can shed paper, and that paper can get into the actuators and the solenoids, cause a lot of expensive problems.